So on the bench I've got my Datron 4700 multi-purpose calibrator, and this I picked up about a month or so ago, and it doesn't work. It's got some faults. Well, I powered it up once and had a little play with it to see what it actually does, and it definitely has some faults. So we're going to pull this thing apart, inspect all the cards, check all those out, and see what we can actually find, because I already had a sneak peek in this a little while ago, and I do know that all the cards are in here, so at least that part's okay. So it's just a case of being a fault on the card. So we're going to try and dig into this. I expect this to be a multi-part video. I expect there to be lots of videos on this particular unit because there's so much to look at on this thing. There's many cards in here. It's going to be a long process repairing it all because it's got loads of tantalum capacitors in here. Tantalum's known for being bad in these things, so it's likely that that's going to be the problem, and I'm going to need to do something about that, which is going to be a case of replacing all the tantalum capacitors, and that's going to take a long time because there's lots of them. Expect a multi-part video on this one, so make sure you subscribe and click the bell icon if you're not already subscribed to catch the videos on this thing, because there's going to be quite a few and I reckon it's going to be interesting. It'd be great to get this thing going. So I've got to get these screws out the side. It's got 3 screws down each side, countersunk in hex ones. Quite nice screws. Like I said, I've already had this thing open once, so I've got an idea of what I'm dealing with anyway. A lot of work to do on this, which is great. It's exactly what I like projects to get my teeth stuck into. The only problem is with this is that it weighs 35 kilos, and it's a bit of a pain to move around and work on, which is why I'm going to be pulling this thing off the bench once I've got the thing opened up and showed you that part. And we're going to pull the cards out and do the cards individually on the bench. But I just want to show you what the inside looks like first. So what I've already done on here is the rack mount parts here. So these were originally a nice hard right angle and sharp, and these are all bent, these rack mounts. And I actually ripped one of my pairs of trousers on them as I was picking up. It dug into my trousers, ripped them. That annoyed me because they're quite nice trousers, those ones. I quite like them. I've now rounded all these corners off, straightened all this out, so these rack mounts are now nice and straight, and the radius so they don't catch on anything. There's that problem gone. So this has to all come out. Someone has already been in here at some stage. They actually marked all these screws already to show which ones to pull out, which I thought was quite nice and helpful. All the ones down the sides have to come out, and those ones which are circled have to come out. So I'm going to get that done. Right, and there's the inside. I've taken the top cover off, and that's what it looks like in there. It is absolutely crammed. This is why it weighs 35 kilos. Very robustly built. So this is all power supply section here, and that's output section over here. And obviously these are all the control cards for various functions. There's a lot to it. Interestingly, there's a switch over here, 50 volts or 400 volts. I don't know what that's for yet. I haven't read it in manual. I haven't actually read the manual. I probably should do. But I'm not going to do that today. Now, there's a few other little switches around. There's a switch over here as well, and there's a few dip switches I did see somewhere. I thought I saw some dip switches somewhere. This card here has got a stack of reefer caps on it. I'm only going to worry about those if it's high voltage. Hopefully it doesn't actually matter that there's reefer caps in here. Otherwise I'm going to have to replace them all. We'll get to that anyway, we'll do these cards. But yeah, there's loads of caps in here. There's loads of big caps right down the bottom here, on the bottom on the main board, which you have to take the bottom cover off to get to. And these cards they'll just drop in, which is nice. Got the upper section over here. Some big heat sink stuff in there. I haven't pulled that apart yet. All I've done so far is I've pulled the top cover off and had a look inside it, and pulled cards out and looked at quickly some of these cards. I did find a fault in one of the cards, which we'll get to. And obviously the main power supply is over here, which I'm definitely have to pull out and check all the capacitors on that. Make sure that's working correctly. And there's lots of things I'm going to have to do. There's power supplies and check ripple on and that sort of stuff. But I'm going to pull the cards out first, inspect all those, fix anything we find on the cards. We'll go through that and recap the power supply over here to get that part done, I think. And then I'll try powering it up again, because there's big caps down there. There's big ones, big bulk caps which down here. They generally don't go that bad. So even if I do start to fail, they'll still be doing something. They're generally pretty good, those big ones. So I don't think replacing those is particularly urgent. I will probably still do it if they're measuring badly. I don't think they're going to be particularly urgent. It's more likely to be the smaller caps which are in the power supply over here. Lots to do. Right, so here's the first card, and it's upside down. As Dave will say, the electron's going to fall out. So you can see here we've got several tantalums on here. There's loads of them scattered around. So this is a little bit of a time involvement to get those changed, but they all need doing. And also got a battery on here as well, which is a lithium cell. I'm just looking to see if I can see anything blown or damaged. I've already had a look over this card originally when I first got it. I didn't notice anything then, but that doesn't mean I didn't miss something. So no harm having a bit of an extra look. We'll have a look on the back of the board, see if there's any signs on the back of it to say anything's been replaced. Now there is a bit of flux residue up here, What's that? That's that button up there, it's a push button. I'm not touching that button. That might wipe the calibrations or something, who knows. If I put this card face down, it's going to press on that button. Now, what does that button do? Does that wipe the calibrations? I don't want to recalibrate it if I don't have to. I'm hoping this fixing it will be enough. Anyway, as I don't actually have much in the way of good references, I'm trying to do calibrations with a bit of a nightmare as well. So I don't want to push that button. Let's measure this battery, make sure the battery looks okay. But visually this car looks okay apart from the fact it's got a bunch of tantalums on it which have to go. Oh, what's that? There's a little bit of black plastic that was on my finger. Where does that come from? Oh, that's one of those little tabs, compression tabs. So somewhere there's a little push tab which is broken off. Do I have something here to show you? No, I don't. But this looks like one of those little push tabs. You've got those little plunger thing, like I've got in the Datron 1062 multimeters. On the one hold the boards in, you've got those little push tabs, you pull them up. I forgot what they're called now, you've got a certain name. I did actually find a source for those, so I bought a bunch of them, so I'm not too worried about those being broken and thrown in, because I have spares. Right, let's check this battery, see what's going on here. So 3.7, that looks fine. That's not looking like it's got an issue. I think that probably has been replaced already, but there's no date on it unfortunately. It's called an AA size. It's a TL5104. That's what it's marked as. But it's an AA size, which is fine. I've also got the EPROMs on here. The date codes on these are 1988, 19th for the 4th 88. So it's 290141-4-2. And 290140, 290139 and 290138. Backing those up might be an idea. There's also potentially a PROM over here because it's got 290122-1 marked on it. So that's probably a programmable device as well. Likely to be some kind of PROM. Anyway, you have to be careful what you do on these boards because if there's RAM, which there will be, you could lose the calibration constants if you're not careful. So I'm not going to put anything on this I need to. EPROMs will be safe. But other than that, got to be careful. So I think that board's looking alright. I'm just going to slot this one back in again. So here's the next card. Thankfully there's tantalums on here. There's one over there, one there, one there, one there. And the rest are all ceramics of some kind. Dip ceramics or monolithics. Not too bad for tantalums on this board. Look on the back, see if there's anything on the back which shows up as being reworked. It's always a clue about this history. That looks factory, there's no signs of any rework at all on the back of that board, which is great. I'm actually tempted to replace the tantalums on this board and mark this one as done. So I'll put this board back and look at the next one. So here's the third board. Now this one's a bit more interesting, there's a bit more going on in this one. So we've got, I don't know, a dozen tantalums on here as well. There's a switch which is in position number 2, making note of that. There's a few links and stuff for doing test points I'm guessing. This is the voltage reference board. We have some reefer caps. So 6 reefers. No, sorry, 8 reefers. No, more than that. There's more underneath there. Oh, I don't know, I think we've got about 9 reefers in there actually. So if I see any cracks I'll be concerned about replacing them. If you see cracks then yeah, you got to replace them. But these are looking good. I don't see any cracks on these. I guess it's because I don't have the same stresses applied because they're not on the main 240 volt system. They can stay as they are. I don't have a problem with them if they're in that kind of situation. Like in the Datron 1062 multimeters, they've got a reefer on the Analogue board on that thing, and it's the same as these. It looks fine. So I don't have any problems with these. These are all 0.47s, looks of it. All of them are 0.47. Yeah, there's some tantalums around. I don't see anything blown, particularly burnt resistors, that kind of thing. We've got these two ones here which are, I don't know if they're slightly discoloured or not. There might just be the band markings. They could be discoloured. Let's have a close look at those. So just here and just here, the ones I'm looking at, I'm trying to determine if they're discoloured or if it's just the band markings. There's another one there, I think it's the band markings. I think there's a black band in there on the brown which makes it look like it's burnt. I think that's what it is. I don't think there's actually a problem with those. Yeah, I'm pretty sure that's right. Let's look at the back of the board. Interestingly, we've got a tantalum tacked on the back with hot glue. And it looks like a little bit of flux residue around here. That's on the back of that switch again, so probably nothing. There's a bit of flux over here, a little bit there. Might be nothing. That's by some through-hole pins for the PCB. And that's a resistor leg, which this side looks fine, I think. There's a bit of flux residue on this side as well. I wonder if that one's been touched up by someone at some point. Just a little dot. It's almost nothing. And over here is a bit of flux residue just there as well, a tiny little bit, and a bit up here and there. I think someone's been doing some touch-ups on this thing. Yeah, there's not much, so there's nothing really stands out. It's like an IC being replaced and all that. But this tantalum being on the back of the board is interesting. One thing that's a factory modification. It's got some hot glue holding it down. It's on the IC here. It's the MC14001UBCP 4001. What the hell is that thing? That is a NOR gate, isn't it? Quad NOR gate. Surprisingly, that on there. Bit more interest in this card, bit more going on, bit more to look at. But nothing obviously wrong, which is a good thing, I suppose. Next board. So here you are, next board. So these look like precision resistors to me. The manual will obviously tell you what board this is and what they do. Now, one thing I do see on here is a jumper plug, which is here, and it's on pin 1 and 2, if the board's out the other way. It's on that side. There's another couple of jumper plugs around here as well, so these may be options or calibration settings of some kind. Not quite sure. That one's look like it's falling off actually. Let's just plug that back on properly. Oh, it doesn't want to move. Maybe it's alright. So we've got a few electrolytics around the place. There are some tantalums as well. Again, I'm just looking for anything that could be burnt, any band resistors, blown tantalums, that kind of thing. Because I'm expecting to find blown tantalums. I did find one when I did my preliminary check, but we'll get to that. But there could be other things which I missed, which I said before. So there's a few jumper links, a whole bunch of relays. It could even be bad relays, you never know. Relays not switching over. They don't work forever. Well, not see anything bad on that side. Flip it over. Yeah, okay. So that tantalum I think we saw on the other board, that looked like potentially a factory bodge, and these are done exactly the same way. So I believe these are all factory bodges. They may even be revision changes. Now sometimes they revise the board and they change the board slightly over time, and it could be these are changes after they've originally manufactured it, and so they do later revision, they'll be retrofitted modifications. But on this board I'm seeing a lot more flux residue, so I'm seeing some down here, some up here, a bit there. So that's on a diode. What's up here? That's on a capacitor to transistor junction. Got some up here, which is on a capacitor. Now there's some here and here and here. Now I think those look like they're very similar footprints. What's that lot? Okay, so these look like transistors, but they've only got 2 legs. So I'm not quite sure what those will be. That might require more investigation, but all 4 of those have got solder residue on them. This IC here has got solder residue. 8746. This looks like its original part though, so maybe it's just been touched up. So nothing really stands out. I mean, obviously that's been resoldered, which is interesting. So that may be a sign of a problem in the past. Nothing really that bad. As that's an original date code, it's probably fine. So next board, and this has got quite a bit going on this one. Got some local regulation, looks of it over here, potentially. So there's loads of tantalums on this one, it's probably a dozen. So I'll be recapping this whole thing anyway. I've got all the tantalum caps, all the electrolytic caps, as a matter of course, because I don't want to be messing around with this thing. And you know, the caps might, even if you measure them now and test them, they come out okay. In a year's time it could fail because it's only borderline now. So I do tend to just do a blanket replacement. Anything I want to keep and it's worth investing the time and money into, I will just do it. I'm not going to mess around scrimping on it, I'm just going to do it. What's $20 worth of capacitors or $50 worth of capacitors on something which is worth $10,000? You know, it's just not worth it. Just do it. Because these things are retailing for like 10 grand working on eBay. I think it cost me about 4,000, I think it was 4,000 or 5,000 by the time I finished paying all the shipping and all the fees and import duties, stuff like that. It cost me about 5 grand, I think it was in the end, for a non-working unit. So yeah, I'm motivated to get it working, obviously, because I've invested an awful lot of money in this. I'm not going to be scrimping on $20 worth of caps, or you know, whatever it will be. I think I've spent about $200 worth of caps actually, just on tantalum. I think we've spent $200 buying parts. It looks okay, there's no signs of rework on the back of the board. Another little factory bodge over there, but nothing really there shows up. This board looks fine, apart from having a bunch of tantalums on it. Just double checking in case I missed anything, but I think it's good. We'll go to the next board. The next board, quite a few relays on this one. Wow, there's a bit going on this one as well. But usual thing, we'll look see if anything's bad. There's less tantalums on this one, which is good. That's 4 here in a group, 5. Well, that's probably 10 tantalums that I can see straight out. So not too bad, but oh, there's some under there too. So there's probably a dozen tents. So that cover will have to come off. I'll have to get underneath here and replace those as well. Plug-in module over here. Position resistors, here we go. That's obviously a little resistor reference board under there. And there's a couple of jumper plugs around, so that's on the pin 1 and 2 over here. Top 2 pins on that one. But again, nothing really stands out as being bad, which is great. I mean, I don't want to find a whole bunch of blind components in every board. I've been through that scenario with the Fluke 5200A calibrator, which had every single board had a fault. That was why it's a 19-part video series. So the back of the board here has got some rework over here by what's presumably an op amp. It's a circular footprint, so that's one of these metal can ones. And there's a little bit of rework over here, a couple of spots which look like, oh, a fuse. Let's check this fuse since I just found a fuse. Let's see if it actually works. You never know. Could be a clue. Yeah, that fuse is good. It's looking pretty good. Now really while I'm handling these boards, I'm touching the boards, and I probably shouldn't really be doing that. I should be using gloves to keep my oils off the boards. But as I'm going to have to do recapping on these things anyway, I'm going to be handling them and all sorts, so I'm going to have to clean the boards afterwards anyway. So really shouldn't be handling precision boards without gloves on. But they need to clean afterwards anyway, so it's not really going to matter that much. So here's the next board. This has got a bit going on this one too. Got a 4-wire resistor right here. Bunch of relays. Some precision resistors over here as well. 99.980K. So sometimes they'll do resistors which are positive and negative coefficients. What it means is if you've got a resistor which is, if you get a temperature increase, the resistance might increase, which is typically how resistors work. But you can also get resistors which go the opposite direction. So therefore, if you get a temperature increase, the resistance decreases. And what I do is I get two of the same value, put them back to back. So one will offset the other one. So if one goes up, one goes down. And it helps to give you the average of the two, which means you've got a more stable reference. That's one of the tricks they use, especially like the Fluke does that quite a lot. The 5450A, which I've got there, they do that in there. Back-to-back resistors, different coefficients. Aha, here we go. Here's a blown tantalum, right there. Right, we found something. And there's a bunch of fuses over here as well. So I'll check all those. We'll check on the back. No signs of rework. That looks perfect on the back. So I'll check these fuses, and we'll replace this tantalum. We'll have to find out what that is. But we'll do that now. Since we actually found a fault, I want to resolve it. Check fuses first. Fine. Fine. Those fuses all check out good. Also got a catalytic resistor over here. There's definitely a resistance board. Don't see any more fuses around, so I think that's it. So I need to replace that tantalum and find out what the hell that is. So we need to find out what this board is and what that tantalum is supposed to be, and we'll replace it right now. So there's the tantalum. As you can see, it's blown apart. The top of it's completely gone. It's black. Usually what happens is you get a big crusty mess. Just a lump of carbon. This is actually blowing the top of it off. So I'll just measure the resistance across this capacitor which is blown, as suggested by one of the people in chat. Thank you, Dave. And I'm getting currently 3.3. It keeps on changing. So that capacitor is blown out, but it's blown itself clear. But it's also scarred the one next to it. Those are both 25 volt capacitors, and they're on a 15 volt rail. The tolerance is nowhere near big enough. So what I'm actually thinking about doing, I might replace all the tantalums on this board and just do this one board. And then I can mark this board as done and not have to revisit this one again. Electrolytics, I don't see any on here. 2 or 3 tantalums underneath this panel here. I have to figure out how to get that off. Probably take it off from this side and be really careful about these wires and not pulling them. Although it's got a plug on it, so that could be handy. Might be able to unplug it. Yes, I can. I'm going to unplug that board. So we'll take this off, and then we'll start looking on replacing the tantalums on this board. And hopefully I've got all the ones I need. I hope so. So that's just some precision resistors on the heatsink. Nice. So there's 4 tantalums underneath there. So we've got to do 5, 6, 7, 8, 9, 10, 11. Thankfully I should be able to read most of them rather than having to look them up in the diagram, because that's a bit of a pain trying to find the things. But these two here I know are both 22 microfarad. 22 microfarad tantalum, not electrolytic. down. Did mailbag videos yesterday, so I've got stuff laying around. So what we got here, these are what I purchased the other day. That's 33s. And I should have 22s in there as well. 22s, 35 volt. So that's those ones there. We'll put those in those. They're somewhat bigger. So before I pull these things out, I need to check polarities. So they've got a junction together. See, the bottom leg of that one goes to the top leg of that one. So that means that is a 0 volt common there. So one is the negative rail, one's positive rail. And I think this is the negative rail, that's the positive one. So I'll have to make sure I put those face to face. Then those will be the correct polarities. I'll get that right to put them back to back, not face to face. So I'm going to put some fresh solder on these first to help get them off. It makes the job a bit easier. Alright, so let's desolder these things. One, two, and put new ones in, back to back. But really the reason these things are failing is because when Datron designed this, they didn't allow enough tolerance on the tantalum capacitors. I mean, they're below their ratings, but the ratings need to be exceeded by quite a bit in order to be safe for these things. Now it's a bit fluxy, that solder, let's use a different one. I'll use my silver solder for this. Okay, so that's done. I'm going to have to repeat the whole process for the whole board. So I'm not going to record the whole thing, but that's 2 of them done, which I know are definitely going to be bougie. If they're not on a main rail, if they're on like a 5 volt rail, it probably wouldn't matter if it's only on a 5 volt rail, because the tolerance is so great, it should be fine. Right, so there's the board. All the tantalums have been replaced now. I can put the little daughter assembly here back onto the board now. I've cleaned it with some circuit board cleaner and some IPA to try and get any residues off, because it's a precision board, so anything like that, because I've been touching it all over the place with no gloves on, it could affect leakage across the board, so I've had to clean it. Hopefully it's cleaned well enough. It does still appear to be a little bit of residue in some spots around here, but I think it might still be drying, I'm not sure. Or it's still running off. Might need to give that area here a bit of another go. I'm not sure that's okay. The rest of it over here looks alright. Anyway, put this back together, because that's where that residue was. Was it this one? Had the board? The op amp had work on it? Was it this one or was it another board? Can't be now. Anyway, probably less critical around these digital sections. Most of it's going to be this area, which is the important part, because this is where the resistors are. Right, we'll leave that to drain off again. I might drain it this way. So I finished the last board, reassembled it, put it back together, put it back in the unit, cleaned it all obviously. We'll see how that goes. Now this is the next board. It's got a couple of electrolytics standing up on here. They might need doing, but it's interesting, got an axial and like a radial positioning. So there's electrolytic here, a couple here, although there's no signs of doming there. So I think I should just replace the electrolytics on here. There are a bunch of tantalums on here as well, quite a few of them, but they look like quite small ones, like mostly 1 microfarad by the looks of it, maybe some 10s. I don't see anything bad. Now it's got some interesting bits in here. It's got a couple of what look like neons up here, which are curious. Have to be careful of those, not to damage those. They look like neons. I'm not seeing any signs of leakage on the caps or anything like that, so they're probably alright. Look at the back of the board. No signs of any work being done on it. This area here is darkened, so it's supposed to be getting hot in this area, which is where that heatsink is from that device. So yeah, heatsinking could be better, I suppose, if it's aging the board like that. It's not good for it. That's an BUZ50A. It looks okay, apart from the fact it's got some electrolytics on it, so I might just put this one back in again and say, yeah, right. I'm obviously going to revisit this board and replace all the tantalums, replace the electrolytics. Whether they test good or not, I'm going to replace them. But I'm not going to do that right now, so it'll take me an hour. So, I'm not doing that right now. Right, it's the next board, little sub board. Not much going on here, which is quite nice, but I've still got 4 capacitors which need replacing. It's got a couple of big pass transistors here, but this side looks like it's got nothing of concern. Flip it over, no signs of any rework, so this board's probably never been touched. But I'm tempted just to replace these parts now. Whilst I'm in here, I can just do this one. So at least then I've got 2 boards, which actually I need to put a stick on that other board, mustn't forget. So I'll just desolder these 2 caps. I'm going to put the new ones in, same ratings, although they're physically somewhat smaller. I just wonder if I can actually put a larger value in. Then I did the tantalums because there's only 4 of them, and get those done. Then this board can be marked as finished. I've got so much to do on this unit, the more I can do in one go the better, I suppose. But equally I don't want to go diving down rabbit holes, replacing parts if it not necessarily that board's even the problem, but as is electrolytics on here, thinking, yeah, it's worth a look. Although the output board had the electrolytics on it too, but they looked okay. And they decided these ones. But this is a simple one to fix. Simple one to do. So let's replace these. What have we actually got anyway? 1 microfarad, 35 volt. That might be fine actually, 35 volt. So is that one. And the big ones are 10 microfarad, 10 microfarad. So yep, 2 10 microfarads there. So I've looked at the circuit diagrams just now, and those tantalums here on low voltage power supplies, so only like 2 volts or 6 volts, I think it was, or 8 volt supplies, and like that. So these are nowhere near being stressed. These should be absolutely fine. So I don't need to replace those. There won't be a problem with them. Electrolytics, yes, I mean they probably will need replacing. Interestingly, on the circuit diagram it said 63 volts, but it had 100 volts installed. So anyway, it's 100 volts again, so it's upgraded, which is fine. You know, let's give us a clean. Get the stuff off here, and I can put the thing back in again. So here are the 2 power supply boards which I just pulled out. I've had a quick look already, just a really cursory one. These 2 caps are bulging. This one's bulging quite a bit. That's got a slight bulge in it, and they look like they're extruding slightly. At least these 2 look like they are. They're staying off the board a little bit. So we've got an issue on here. There's some tantalums, of course. Tantalums over here as well. This one's looking like a simpler board. Let's check these fuses because it's got a bunch of fuses on here, see if any of those are blown. But we definitely have to do some recapping, there's no doubt about that. Right, fuse here, looks fine, but that's okay. Fuses here, good, good. All good. Okay, so there's no blown fuses. That's actually slightly surprising. There's lots of fuses through this thing, it's quite good in a way. The whole unit's got fuses everywhere. So we've got a bunch of 40 volt 1000 microfarad. That looks like that's what they all are actually. These are 63 volt 470s. Both of those. So 2, 4, 6, 7 1000 microfarads. Got a couple of small ones around the place as well. 1000 microfarads. 16 volt, 25 volt. I don't have enough capacitors to replace all of these. If they're in parallel, then I might be able to just put in a larger value across one hole. For example, take 2 parts out, put one larger value in one spot instead. So it's the same capacitance. These 2 caps are linked together over here, but I can't see the other trace in the top side. I can see a trace there now. Now I can see it. No, that might be positive and negative supply. Those 2 might be in parallel. Those 2 there. There's a trace between those ones. I can't see where it goes. Those 2 are in parallel as well. So those are in parallel. Those are probably in parallel. Those don't look like they are. So if I've got some 2200s, that'd probably be right. What do we have here? 25 volt. Well, I've got 25 volt caps. I think because these 2 boards go close together, when they're actually in the casing, they sit like this, basically touching. So they're almost touching. So the height wise, I have to be considerate about. But I think I've got enough clearance on this one. I might be able to upgrade that one to make that one better. So I've got a 15 at 450. Although the height's a bit pushing it, I think. So I pulled all these capacitors out. These are 1000 microfarads, 40 volts. I'm replacing them with 63 volt versions. That's what I've got on hand. I had to go digging for them, but I found them, thankfully. So now I'm just going to solder these back in again, and then we'll go through and see what else I can replace without having to order any more parts. I think I probably will have to do some ordering. It would be nice to get these power supplies rebuilt and refurbished today so I can do some testing. So I don't want to power it up again until the power supplies are done. So what I did do before I started recording is I cleaned up the pads on the top of the board because they were a little bit oxidised. But the solder hadn't originally flowed through from the other side of the board when I did the original manufacture. So I gave those a bit of a clean up with my fiberglass brush and put some flux on that side before I pushed the parts through, so that would have pushed the flux through the board, through the plated through holes, onto this side a little bit as well on the pad, so it would have flowed through a lot better when I soldered this side. It should have actually flowed solder through onto the other side of the board, hopefully. Right, let's clip these off. So that's those ones done. So we've got these ones over here which are 470 microfarad 63 volt. So we need to look for those. I've got some 50s I think. Now, I've got 50s, but I don't know if that's going to be enough. Or maybe I think I could put the 1000 microfarad 63 volts in here instead of 470s. These might be done that size because of the physical restraints on size, right, in that placement. They couldn't have anything bigger in there for that voltage rating. But I've got these ones, but I've only got one left now. I think. I do have something in this bag. Was it that one or a different bag? Or maybe I do have some more, actually. If I do have some more, I'll replace those, I'll upgrade those to a larger capacity. That's what I'm tempted to do, maybe double them. So those two capacitors pulled out, which are the 63 volt 470 microfarad, they're in parallel together. So I can actually replace those with one capacitor, which is great because I've got one capacitor left, which is 1000 microfarad 63 volts. So that's fine. It's actually upgrading the capacity very slightly at the same time. So that's fine. I'm happy with that. So we'll just solder these on. Now actually what I'll do is I'll resolder the original pads as well on the other one, which I'm not replacing. This has got a solder link between each side of the board, just to help reinforce it in case it's required for current handling capacity of the power supply. I've been relying on the through-hole plating, because before it did have a component through there to do that job. So now it's got to do this, and make sure it's got some flow through, just like that. It's flow through, not well, but it's through. That one does need cleaning up. Let's give that a bit of a touch up. Didn't flow very well on the side. Didn't have any flux on it either, so that doesn't help. There you go, that's flowed better now. Might do this one that's next to it as well. There's it right here. So, what next? Got a little electrolytic down here, 10 microfarad, 63 volt. That should go. I think I've got a few of those. I think I can spare one. Maybe odd ones I can shove in there in case I've got some random thing. I'm using sets. I like to keep the sets if I can for other stuff. I'll do a random one in there. Let's get that out. This is why you see me buying lots of capacitors in mailbag, because I need them. For these times when I'm working on something and I just happen to need to replace it. Never quite know what I'm going to work on, what I need. That's why I keep a stock. As much as possible at least. Well, let's get this one out. Yeah, it is. Here we go. Right. Which way around was that? I think positive was upwards, wasn't it? I think it was. Which way around was that? Yeah, it was. It was that way around. That's fine. It does have a square pad to denote positive, but don't trust those because they're not always right. So these electrolytics over here, which are 3,300 microfarad. The only ones I've got are radial. So they'll fit, but the legs won't reach. It's not an ideal situation because there's no way I can fold that right round and get it right round to the other end. That is not going to happen. If I use those, I have to extend the legs. Are they in parallel? If they're in parallel, that'd be brilliant. They don't appear to be in parallel, because if they're in parallel, I could potentially use a much larger capacitor instead. Let me double check the diagram. So I've recapped these two power supply boards. The only exceptions of what I haven't done are those two big capacitors there. That's 300 25 volt caps, which test okay, but they are marginal as far as voltages go. There's 25 volt caps on a 22 volt rail, so I do want to replace those. On this board, the only other cap I haven't replaced is this tantalum over here, which is a 100 microfarad 16 volt. So 100 microfarad 16 volt was that cap there, which I don't have in stock. I've only got 10 volts. So I've left the original one in place because what I put in will be worse than the original. So that cap there, these two here need replacing, otherwise those two boards are done. Replaced all these tantalums, everything else is done. So I'm testing these power supplies. I'm now testing the outguard power supplies, which is the plus and minus 15 volt rails for that. And I think I've found a problem. Let's just show you this. Turn the power on, and we're getting a volt or less on that particular rail. If I change the other rail, getting minus 15. So the minus 15 volt rail is there. The plus 15 volt rail is not. It seems to either be loading down or it just isn't working. So I need to look into this one. Right, so what I've done now is I've lifted all the cards up, just unlatched them all, lifted them all up so they're all out of circuit, and I'm going to power it up again and see if we can get a 15 volt rail now, because either the regulator is weak or it's being shorted out. So let's try this. 15 volt rail is now back. So the next thing is to figure out which card is causing that problem. So I'm going to put in half the cards and we'll try it again. Alright, so that's 4 cards in, and we'll see what happens now. That's being loaded. So one of those 4 cards is causing the problem. Okay, let's take 2 of these cards out. Do it by process of elimination. Next one. Yep, still being loaded down. So it's one of these 2 cards. Let's pop that one out. It's back. Right. Okay, but it could still be a cumulative effect. So let's pop this card out and plug that one back in. Alright, so now we've just got the blue one. And that's been loaded. So there we go. We know that this card here is the one that's giving us the trouble. So one last test. I've taken that card out completely now. All the other cards are inserted. So there's one card out now. And that's working. Now it is sagging slowly, but it's kind of stabilising. It's probably fine. So I've got a card to investigate. And this is one of the ones I've already worked on, which so I've obviously missed something on this. I did replace all the tantalums on that particular board. I replaced them all already. So maybe there's a particular problem with that board. Well, there is obviously a particular problem because it's loading a 15 volt rail down.